Hello, everyone, and welcome back to our last session for the Grade 5 new math implementation. It's been a pleasure to work with you all year and to work our way through some of these new outcomes that we have and to navigate the waters of what we can do for applying those into the classroom as far as our hands-on learning is concerned. So today we're going to be covering the subject matter or the parts that we said we finished off in session 4 with, and that was specifically finishing up with algebra. We deliberately left statistics for the last component or the last piece of what we were going to do in the year. And we also want to talk a little bit about the number and patterning that's happening as well. So this is our wrap-up session today, but there's lots of material in here. And so I will be putting links into the chat box as well to help out, and hopefully we can do some hands-on learning at the same time and go through. So to start us off, we're going to begin with our land acknowledgement. And again, with each land acknowledgement that we've been doing in math, we've always put a link at the bottom to try and tie some of the acknowledgement and what we're doing perhaps in our units into some of the Indigenous math infusion into our curriculum. So you do have a link in here. It comes from a source that you probably are well familiar with. I will link it on in just a few minutes, but there's lots of information on the site that I've shared with you. So let's begin. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And I'm sure that many of you have heard of Jo Boaler and are familiar with her work and familiar with her site, UCubed. And this is what I've chosen today, just to connect with our land acknowledgement. Featured on here is the work that was done with Jo Boaler going and working alongside some school boards. But the three people that she's featuring and working with are all Alberta-based Indigenous teachers. And the blue in here will give you the highlights of the lesson plan that they're working on. They're doing patterning. They're talking about variables. They're talking about how they would take a design, an art design, an Indigenous art design. How would they write, make a table of values for that, etc. So it really ties in to exactly what you're going to be teaching. So I thought this might be a nice link, and her work is always amazing, as is the work of these three ladies. Okay, so as I mentioned, we're going to finish up with algebra. We did algebra in 3 stages. So early on in sessions 2 and 3, we touched on the 1.1 where we were talking about numerical expressions, and we went into expanding those and talking about the terminology that sits around expressions as in variables, constants, coefficients, like defining all of that. We did that last time. We'll touch on that very, very briefly today again. And then today we said we would leave this day to look at the tools that we might be able to use to work with equality. So what might that look like in grade 5? And there's some parameters that we need to be really aware of when we're doing grade 5 algebra, because they don't have all of the knowledge that we would want them necessarily to have for all of the solving of equations. So to be very cautious when we get there, to remind yourselves that you want to stay within those parameters. We're going to look at arithmetic sequences, what they've learned about in grade 4, and we're going to move that forward now to grade 5. And then stats. That was the one that we said we would leave until the end. So we're going to talk about statistics. We're unpacking it from grade 4, and it's moving fairly consistently right through the grades, each year with a higher expectation, but with a very deliberate pick up from where you left off from before. We're still using all the tools from the previous grade, but we're just infusing a little bit more information into it, but they're still doing and engaging in investigations and experiments and doing those things. Again, could be a place where I meld both my math and my science at the same time. That might be a good combination. So we're going to talk about what frequency is, and we're going to look at how we mark that frequency into a table, like how do I record it? We'll talk a little bit about some of the terminology that goes around that and represent that data. So let's start with algebra. And again, because we spread this over 3 sessions, I'm going to just very quickly pick up some of the things that we talked about before. This is something that you have seen before. This is one of the slides that I used previous, and it was created by one of my colleagues in ERLC. And in this particular case, we wanted to remind you that in Algebra Grade 5 is the place that we introduce the terms variables and constants and coefficients and the idea of an inverse operation. That's what we're going to work on today. So we've covered all the green and all the blue. That's already been done in previous sessions. So if you missed them and that was something that you wanted to get some background on, then you might want to go back and pick up some of the previous sessions as well. Today, we're going to focus on those inverse operations to solve questions. But it's important that we remember that this terminology is the first time they've seen it in grade 4. They're not dealing with variables, but they are in grade 5. So this was just a summary page, again, that was created by my colleague who looked at how does this kind of progress? Like, what does it look like moving from 4, 3 into 4, 4 into 5, 5 into 6? Because algebra starts in grade 3. It's not before that. So this is where we can kind of see the growth over time of what that's going to be. And it kind of helps to see too where grade 7 might just kind of lead into. So if I look at the first cusp that we had in algebra, so we did this before, this dealt with numerical operations. So we were doing order of operations. We started in grade 3 or grade 4 formally. And we talked about order of operations. We talked about the importance of an order of operations isn't about giving me an acronym or a short form to remember or a sentence that helps me. The order, it's important for me to know the order, absolutely. And sometimes those acronyms really help us. There's no question. But to be honest with you, we also want them to understand why those are the way they are. So in grade 4, we went through lots of examples. We did that yesterday with the group. We went through lots of examples to show them of when I do it the right order, when I do it in the wrong order, what happens, what kind of answers do I get? And how do I model that for them? It's one thing just to stand up in front of the class and say, hey, this is what you do first, this is what you do next, this is what you do next. But if I don't really understand math to begin with, and math is a struggle for me, then that's, again, just a process, but I'm not really understanding what that process is all about. And so we model that in the grade 4 section. So you might want to go back and have a look at that. But again, just as a side note, it's really important that we understand the process behind or the concept of order of operations. What is it it's trying to do? And why is it so important? Well, it shouldn't matter where I live in the world. We should all end up with the same answer in the end. So there has to be some rules that we all follow in order for us to obtain those same values. Some of the research that's been done also suggests that when we just give them like PEMDAS or BEDMAS or whatever you're used to using, when we just give them those acronyms and just say, this stands for this, this is brackets, this is exponents, this is multiplying, this is dividing, just remember that word. What the research found was that often students remembered the acronym or the word that we gave them or the sentence that you gave them. And it started to just, that was the order, right? Since M comes before D in this particular example, I'm always going to do multiplying before dividing. They failed to recognize the concept of it's either multiplying or dividing, whichever comes first from left to right. And so that was just a caution. And so starting to put misconceptions down as well. This is something we'll try and start to build into the CPAR documents as well to give that little bit of background of what is research telling us the students are struggling with in these particular areas. Well, this is one that they found was that when we just give them that and say, this is how you solve an order of operations, that sometimes becomes the rule. And there's no flexibility if I don't understand the concept of knowing that there's an order in that mnemonic. So one of the things that we might look at is something like this. Now remember that in grade 4, they are doing the 4 operations of adding, subtracting, multiplying, and dividing. So they start with multiplying and dividing, whichever comes first from left to right as I'm reading across my problem, and then I do adding and subtracting, whichever comes first from left to right. The only difference in grade 5 is that we have introduced parentheses, brackets. So then I'm still using my 4 operations, but now I have that new addition. And we need to make sure that students understand that the parentheses, whatever's in the parentheses, gets priority over multiplying and dividing, adding and subtracting. So we need, again, to show students what that might look like. It's not just enough to tell me the rule. I need to get a sense of what are you actually asking me when you're showing me this? And a student should be able to model that for us as well. Like that's an important piece. So if I was to model what it looks like to have parentheses or groups of things in my order of operations, it might look something like this. If I was to use Cuisenaire rods, and our students should be familiar with those at this point, I see I have a green rod and a red one, another green rod, another red. In other words, I have 3 of the same thing. And if I know my Cuisenaire rods just in value alone, that a dark green is 6 and a red is 2. Or if I don't know them, I've put them on a grid so I could actually count them for units. But it's not so much the number that I want to point out here, it's more of the fact that I have a repeated pattern that I'm seeing. And then I have this lone bar that's sitting out by itself. So if I ask students to write an expression, which they've been working on now for a while, what is an expression that would represent this picture? Well, there's a couple of ways that I could do that. I could say, well, this is 6 plus 2, and I'm doing it 3 times. So I could write 3 brackets, 6 plus 2, and then I have this lone yellow one, or 5, sitting at the end. So I'm going to add 5. These are identical, they're in groups, so I could write them as repeated addition instead of going 6 plus 2, add 6 plus 2, add 6 plus 2, which in theory I could do, but we want to be somewhat efficient here and use our tools that we have available to us. So when I write this in groups, that means I also need to know how many are in here. All of these are going together. They are all of the same repeated amount. This is the one odd man out, if I want to call it that. So in order for me to make this the priority, when I put it in brackets, the brackets or the parentheses, whatever's inside those is going to get done first. So in this case, I'm going to go 6 plus 2 is 8, which is true. Each one of these adds up to 8. 3 times 8 would give me 24 blocks already covered, and I could count them to verify that. And to the 24, I'm going to add an additional 5. Another way that I could have done this, and one is not better than the other. I don't want to make it sound like there has to be a parentheses in here. I could have said, well, I've got 3 green ones, or 3 times 6. And to that, I want to add 3 red ones. Those are the repetitive pieces. So 3 times 2. And my loner at the end, which is the plus 5. Either way, either one of these, I'm going to get the same value as I move through. So both ways acknowledge the multiple groups, repeated colors that are in there, and I use parentheses or I use repeated multiplication when in addition to solve that. So we have the opportunity to use Cuisenaire rods to do that kind of modeling, and we should be doing that first. Rather than just putting the numbers on the board, let's let them see what it looks like, and that they can recognize that when something's in brackets, there were things that were grouped together, and there might be just sort of that trailer that's sitting on the end. Well, that's how I could write that trailer that's sitting on the end, that one that's just sitting on its own. So they need to have a visual, and seeing it is always easier than just telling me what that might be. So if we keep that in mind, okay, and I can go back one, you saw what we did here. We put our brackets or our multiplication. I want to give you just a second to think about, these are 2 separate questions. So here's one question and here's another question. So just on your own, you don't have to put anything in the chat box, just what would you write down as your expression? Just jot it down on your table and we'll go through it in just a second. What would that look like? And if you're not sure what those colors represent, remember you can use the squares to work your way through it. So just give you a second to have a look at that first. So as I'm doing this, I see that wherever I have multiples of things, I probably could use multiplication. Maybe I can use brackets. Maybe I can't, but it depends on how I set this up. So I might set this up that the green ones are one part and the pink ones are another part. I might add them together. I don't know. That's up to you to decide what makes sense to you. So I could go 2 groups of 3, and to that I want to add 3 groups of 4. And I have this loner sitting on the end that's being added to both of them, which is 7. So how many squares have I covered? And it's important that we see this work, and important that the students understand that, because in theory, if I only asked you to tell me what's the value, if a child understands that the value means, in theory, how many squares are covered here, I can just count them. And I could just give you the answer. And if all you want is the answer, you will never know how they got that. And if all they're doing is counting the squares, well, I'm not always going to give you squares. So you're not always going to have the benefit of being able to do that. You need to have the tools to work your way through this algebraically. Let's look at the bottom one. I have an orange rod, which was a 10. I had 2 repeated ones, in this case, 2 yellow ones, so 2 times 5. And to that, I added a bar, which has something removed from it. This is how we did when we did subtraction, when we're doing Cuisenaire rods. This is how I can represent subtraction. So I have a value, in this case 6, and I'm taking away a value from it, in this case 2. So this is how I could write that into my expression. Now, some students might look at this and say, well, I know that that's going to be 4. So they may just do that part in their head and just do that as 4. But we want them to actually model what they're seeing. So to model what they're seeing, then they would need to show that it was 6 minus 2. Either way, I'm still going to get the right answer. So the importance of them being able to understand what this order of operations, why are brackets more important? Well, because there's more things happening in those brackets. We need to take that into account first. So some question samples that we might see in grade 5. I've taken some of these from the CPAR document, so you'll get access to these. That one should be up here right away. The algebra one is ready to go. And so I see lots of examples, but a couple of things to note for yourself. Again, we've been saying sort of right from the beginning, right from the very beginning, session 1, is there an opportunity for us to think about maybe not, when we plan for grade 5, having compartmentalized topics? Like, could we move away from, I'm just going to do fractions, and now when I'm done the fractions, I'm going to do this, and then I'm going to do this, and I have a 2-week span in here, so I'm just going to slot this in. Instead, what if we really thought about, what is it I need to be working on at the same time? What fits together really well, and what previous knowledge will I need? So algebra would be one of those perfect examples. Is I don't just throw algebra in wherever. I mean, I could spread it out like we did, but I have to be cognizant that any one of these questions fits into order of operations. This is in algebra, but that means I'm also presupposing that I've already done fractions with you, right? I can't ask you to do an order of operations in brackets where you're subtracting fractions if I haven't done the unit on adding and subtracting fractions first. So again, it's always being aware of where it comes. Could I do order of operations in any one of those units of number as I'm going through? Absolutely, you could. And each time I do a new area of number, if I'm doing decimals or I'm doing fractions, I could just add in a few more questions in the order of operations because we've already learned about how to do them. Now let's just add a different kind of question in. So it just starts to bring some of those pieces together, rather than students thinking that order of operations or algebra is this little box, and once we're done in 2 weeks, it's done, I never see it again. And that's not true of anything that we do in math. They should all be integrated as we go. So here's just some examples. Here's a good one too, where you could give the students these questions and say, where would you put the brackets or the parentheses to make it equal 18 or to make it equal to 3? So just giving them an opportunity to decide where they would put them is a great opportunity for them to show that they know what they're doing. Can I come up with wording? Can I use a variable? So write an expression. I now know how to use variables. So could I use a variable to write out what this expression might look like? Writing an algebraic expression for any one of these. right? So these are just some samples. I'm not saying these are the end all be all. They're just ideas of that fit into our organizing idea that we're unpacking right now. So if we look at that kind of covered A 1.1 and 1.2 at the same time, let's look at 1.3. That's where we said we'd hang our hat today in algebra. And that was using what we've learned so far, the language of variables and all of those pieces to solve an equation. And remember that we said an equation has to have an equal sign. An expression does not. So x plus 7 is an expression. If I say x plus 7 equals 9, that's an equation, and that x only has one possible answer. There isn't going to be endless amounts. But when it was just x plus 7, if I made x 1, it's 8. If I made x 10, it's 17. So I could change that because there was no value that it had to be measured against. So expressions give us more opportunities to substitute values in and to find the values. So equality is preserved by applying inverse operations to algebraic expressions. So what exactly does that mean? It means that often when you were in school too, our teachers often said to us, left side has to equal right side, or both sides have to be balanced, or what you do to one side, you do to the other, right? This has been around forever and a day. These aren't new lines that we've ever created. But the question is why? And the question, or the answer to that question was that we are trying to model the preservation of equality. I don't want the balance to tip. If it's balanced, it's equal. If I take something away from this side that was weighted, and I don't do the same thing on the other side, well, then clearly it's going to go like this, right? It's not going to be balanced anymore. So that's what the term preservation of equality is talking about. And by inverse operations, we're going to use the opposite operation to do that. So if I was adding, I want to subtract. If I was multiplying, we want to divide. So notice what my examples were, and I'm going to preface it right now because that's going to be important. I said adding and dividing. You have to remember that in grade 5, they have not yet learned positive and negative numbers. They've not done integers. So it is not okay to say, I'm going to model x minus 4 equals 8, because you don't know how to show them a minus 4. How do you show them subtract 4 when I don't understand that that actually represents like negative 4? They don't understand what a negative 4 is and a positive 4 is because they haven't gone there yet. So you have to be very careful in grade 5 when you're solving your equations that you are using questions that when I'm using an opposite operation, like adding, opposite will be subtracting, I can take that amount away without worrying about negative numbers. And we'll do a couple of examples of that as well. I also circled for you the verbs that are in here, and these are important ones because you'll see it says write, investigate, verify, solve. So there's lots of doing in here, not a lot of sort of watching, more of getting going. So we want them to have tools in front of them that they could model and that they can do the work. They can do the paper and pencil on the side, but they don't have to do it this way. So when we're talking about that preservation of equality, we're talking about, can we keep things balanced? And here's an example of this question works well for grade 5. Why? Because I have x plus 4 single units on this side, and it happens to be balanced out to start with. We always start balanced. So whatever equation we give the students, we say it's balanced, right? You got to know it's balanced. So that means that whatever x is, it's balancing out whatever's over here. So I have these single ones over here, which happens to be 7. I have x plus 4 on this side, and it starts balanced. If I wanted to take something off of this side, what if I just wanted to take one of the cubes off of here? If I just take the 1 cube off, well, clearly it's not going to be balanced anymore. It's going to start going down on this side because this side's got way more weight on it. So in order to keep this line balanced, I take the 1 off here, I have to take 1 off here. If I take another 1 off here, I have to take another 1 off here. So in the question like this, x plus 4, if I say I want to subtract 4, in other words, take away 4, I can do that in grade 5. I can count down 4 and take 4 of these off the top. And that will show me that x is actually equal to 3. One of the terms that we have in grade 5 and for grade 4 is to evaluate or to verify. So when I know that x is equal to 3, this block was actually equal to 3 of these ones sitting in there. That's why it was equal to start with. I can take this 3, put it back into x plus 3, or x plus 4, sorry, is equal to 7. 7 equals 7? Yes, it does. So this is that inverse operation, but caution that we have to make sure we set them up with questions that they could model taking it away without worrying about whether we have a negative sign there. So another question might be something like this. Tom pays a total of $22.25 for a pizza with some toppings. If there's a pizza without toppings, or just the basic kind, it would be $18.50. Write an equation that shows the cost of those extra toppings that he had to pay more for. So the basic pizza, add, let's say, T for toppings, equals $22.25. And when we do an equation like this, we don't put symbols in, they don't put the dollar signs in. The yellow arrow here is just to remind us that when we are using variables with students and you're typing them out, if you're going to ask me a question, a variable is always lowercase and it's always italicized so that it just stands out from regular type so that they see that as a variable. And that's kind of a norm or a standard that we use. Substitution refers to taking the number and putting it in where the variable was. And how do I know that you're substituting? How do I, as a teacher, know that you're showing me that you're substituting? We tell students that whenever you take a value, our value was 3, whenever you put it into a variable, substitute it into a variable, you put a bracket around it or parentheses around it. And that's the indicator of the flag that I am taking what I believe to be an answer and substituting it into what used to be a variable right here. 3 plus 4, 7 equals 7. Yes, it is. So teaching students that little step would be a helpful piece as well. So let's go to using some tiles. They definitely can still use the tiles in grade 5. They're just not going to use negative tiles because they don't understand what those are all about. Those we're going to reserve for grade 6. But in the set that I'm going to put, I'll put this in the chat box for you right away. We're going to use from Didax. That's one of the places that you can use virtual manipulatives. We're going to mark the red ones. Anything that's red is negative, and anything that's yellow or green is positive. We won't worry about the bigger sides. So let me just grab this one. And if you want to load it onto your computer and then you can follow along with me, we'll just do a couple of them. We won't do a lot of them. But I just want to make sure that everybody's comfortable with them before we move on. Okay, so let me just throw that in the chat box. Okay, it's in there for you, Rhonda. So in our previous question, we looked at a balance scale, right? So this is the same idea here. We're going to use that line in the middle with the equal sign as our balance scale. When I do this with students personally, I just have a piece of paper. I just laminated manila tag. I just use the larger size manila tag, and I don't use the 8.5 by 11. I use the 11 by 14 or larger if you have it. And I just laminate that with the scale already on it. And so that they understand, just keeping in mind, I want it balanced, right? So that they're always thinking about what I'm doing, that rule about what I'm doing to one side, I'm doing to the other. I'm understanding why I'm doing that. It's because I want to keep that balanced. So here, this is going to be kind of our balance scale. This is the tipping point, and we want this side and this side to be the same. So let's set up a simple question like, let's do x plus 3, let's do a different one. Let's do x plus 5 is equal to 8. So remember that the reds are negative, so we're going to grab, this is my variable. When I'm using algebra tiles, the rectangles are variables. We'll call them x's, you could call them m's, you can call them t's, you can call them whatever you want. But we said we're going to do x, and we want 5. The red is a negative unit, this is a positive unit. So it's like saying this is a penny almost. I want 5 of these over on this side. For those of you who have money in the classrooms, doing this with money is a great one too. Just having money on the side instead would be another way to do it. So here's my x plus 5. And then on this side, we wanted 8. So I need to drag over 8 of those. So go ahead and do it along with me. I just want to make sure that you're all comfortable with that. Now, there's different versions of algebra tiles. They'll have different colors on them as well. Some of them offer slightly different ones. Some of them you can write the question right on here. This one doesn't allow the question writing, but there I have lots of other ones that do. So whichever works better for you. So in this case, we had x plus 5 is equal to 8. So whatever's sitting in here is making up for whatever's over here. And yes, by the time they get to grade 5, when we say x plus 5 equals 8, most of them will say, well, the answer is 3. Yes, it is. But now I want you to show me that it's 3. I want you to show me how you would get 3, because I need to know that what if it was a more difficult question where you can't just pop it off the top of your head? How would you solve it? So that's the process we want to go through. So we'd like to know what the value, what's hiding inside this green? What is the value of a single x? That means that I don't want x plus 5. I would like to have x all by itself. So to isolate the x, or to keep it by itself, that means I need to remove these 5. But if I take 5 away on this side, this thing's just going to drop if it was a balance, because definitely this is going to weigh more. But if I take 5 away from here and 5 away from here, I won't have an issue. It will remain balanced. So if you take your eraser that's just down at the bottom here and grab it, I think if you just click them on, it should work. Yep. So I click on 5 of them over here. I click on 5 of them over here and do the same thing here. And I end up with x is equal to 3, which is correct, right? So I can check it. Does 3 plus 5 equal 8? The answer is yes, it does. So I know that that's a correct answer. Okay, so let's try another one. If you press that little circle one, it'll just clear it out for you. Let's do one this time that has more than a single x in it. So let's try 2x. So go grab 2 x's. We'll just do it a bit at a time here. So 2x. Let's make them small so it doesn't take too long. Plus 4. And then equals 6, just to make it quick. Now, when the students are doing these, because algebra tiles are easy to do on their desk, they can simply slide 4 off of the left with their hand and 4 off on the right with their hand. They don't necessarily have to be doing this on paper and pencil right off the bat. And I would never start solving equations like this until they're so proficient at doing it visually like this. Once they've got this process in their minds, to change this to the symbolic is easy for them. And so once they're really good at it, then over on the side, I would have a piece of paper where everything that you give them over here that they're modeling, each time they do something, they're also going to do it symbolically over here. So they start to see as, oh, you know, I can use this anytime I want, but I actually can work it out also just using the symbolic. So I have 2x plus 4 is equal to 6. So again, I would like to know, what are the numbers that are housed inside these variables of x? And they both are the same. These are both the same letters. So that means I'm going to have to figure out what one of them is equal to, not 2 of them. I'd like to know what is a single x equal. So I'm going to do the same thing. I'm going to take my eraser, and I'm going to get rid of my 4 that's over here and my 4 that's over here. Now, just to save me time right now, I'm just going to grab 4 of them and pull them down as if the students took them right off of their page. And I'm left with these 2 x's over here is 2 over here. So it's like that equal share that we've already talked about once before. If I have 2 x's on this side, whatever's left over here to stay balanced, I'm also going to give it an equal share. So this one gets 1 and this one gets 1. If there were more, we just keep going equal share. In this case, 1x is equal to 1. So 2x plus 4 equals 6. If I substitute 1 in, it would be 2 times 1, which is 2, add 4 equals 6, which is correct. So I have to be cognizant of the numbers that I use are things that the students can easily take off. If I wanted to, I could have also said, let's just do it here, because if I'm doing this symbolically, like when I start marking it on a piece of paper, I would have 2x is equal to 2. The opposite of multiplying 2 times x would be dividing both sides by 2. I would divide both sides by 2. So that would leave me with 1x equals 1. Either way, whichever way you want to model it, you're going to have to get to the division at some point. But this is where being a little cognizant about what numbers you use with the students in grade 5 will be important, because they don't know how to deal with the negative numbers. Okay, so that's just sort of a starting point with that. Another example might be something like this, right? So once I get really good at it, I'm certainly not going to do algebra tiles and have them pull out 89 tiles. That's just not going to work, right? So that's important. Sorry. So why is the green bar X? Okay, so let's go back. That's a really good question, Rhonda. Let's go back to that for a second. So in algebra tiles, have you used algebra tiles before? Is this new, or is it something that
No.
you no? Okay.
So no, it's new.
All right. So algebra tiles were designed to do exactly what we're doing here, and then they go even bigger. Like the more we add to algebra, the more you use these. That's why there's big squares here, and we're not going to use those today. But just so that you understand the premise behind these. The rectangles are related to the squares, and let's ignore the color for a second. If I were to line up the rectangle with the square, you will see that these actually fit perfectly. So when I look at this and I call this a variable, we tend to call them an X. In algebra tiles, there are 2 different color combinations. There's an X letter, just so that we have a variable that we could work with. And it could have been any letter you want, but for most cases, when you look in books, those rectangles will be referred to as an X, the longer rectangles. And the reason I'm saying that is because there are double sets of algebra tiles. This would we call, if I want to call it the standard rectangle, it's the X. The Y variable, just so that we can have 2 different variables, because as they get into grade 9 and 10, we start to get 2 variables happening at the same time. The Y variable is different than the X, and just so kids don't confuse it, it's a little bit shorter. It's about 2/3 the length. They're related in that the length, or the ends of them, are exactly the same height, but the length of the rectangle itself is different. So we have an X kit of bags of tiles that you can get, and then there's a Y bag of tiles that you can get. You can also, from previous years, when you buy the bag of tiles, you get both. You can now request only X's or only Y's, but for our purposes for grade 5, we're never going to use more than 1 letter at a time per se. So just having this is the way it goes. The color is insignificant. The reason that we have to say up front which is going to be positive and which is going to be negative is exactly that, is because the color can change. I've got sets in here that I've used for 30 years, and they're the traditional green, white, red color. That's what most of the books are written on. That's what you see. That's where lots of them are still done. However, the new kits come out now in red and white, or they're coming out in black and red, or they're coming out in blue and yellow, or they're coming out in red and yellow. So it's important that when I start working with them, I say to students, this is what a positive is going to be. This is what its negative is going to be. In grade 5, since I don't know what a negative is, all they need to know is that I'm going to work with the green ones today. Could I say that I'm going to work with the red ones today and just say, we're going to call this our X and this is going to be our 1? Sure, you could, because they don't know that a negative exists. So I can be quite versatile in grade 5 and use them. But when I try to figure out what this is, and a lot of times when I bring these out, kids will say, well, what about this big guy? Like, what are you supposed to do with that? And I say to them, let's just pause for a minute. We're not going to use it today, but let's just see what we remember from squares. A square has all of its sides the same length. This rectangle happens to fit perfectly on top. It's called an X. So that means that if I put another one right over here, an X times an X would become an X squared. So this is where we're getting into the higher level math already. Grade 5s will never go there. I say this is a bigger one. It's the area that's defined by 2 rectangles getting multiplied together. But we're not going to use that one. So we just leave that one in the bag so that it doesn't confuse issues and stay with the rectangles to be the variables and the small ones to be the units. Even in grade 5, I say to them, you don't deal with other number systems like negative numbers, but they do exist. And so I do tell them that each one of these has a different value. That being said, it's important that we don't just stereotype whatever you have in the school to be this color is always positive and this color is always negative. Tomorrow I could come in and say to you, if we were doing another lesson, today the green is going to be negative and the red is going to be positive. And the reason I say that is because in any PAT exam that we have, they always have a legend, and the legend has to be there to say, this will be the positive one, this will be the negative one. So I have to know what the rule is, which one's going to represent what kind of value. And same thing here. And so I always try to use different things so that the students don't get stereotyped into that, and kind of get drawn down in the wrong direction. They have to look at the legend. I could even switch it up and use these little squares and maybe go grab the hexagons from the pattern blocks and say the yellow hexagon is going to be our variable today. So I want you to show me 2x plus 1 again. So, okay, you show me 2x plus 1. So 2 yellow hexagons plus a 1, or whatever, whichever one you're going to use. So it's just so that they understand it's a placeholder. The variable is nothing more than a placeholder. But that's the reason we call it an X. There's an X kit and a Y kit. Could I start them off and say, what's your favorite letter? T? Okay, let's use T's. These are going to be our T's today. These are going to be our M's today. Absolutely. There would be nothing wrong with doing that at all. So I don't know, does that answer your question?
Yes, thanks. It's really helpful. I was wondering if there was a link in the resources of where to order them for the hands-on.
There isn't, but you know what, Rhonda, I can send that to you for sure.
Okay, thank you.
Yeah,
all right.
you bet.
Thanks for taking the time. Thank you for that.
Yeah, no, for sure. The algebra tiles are very new. They're not new in the schools, but they definitely are new for this division because we haven't really focused on them as much. But now that the integers are being going to be talked about in grade 6, grade 5 is a great place to introduce the algebra tiles for the first time, so that when they get to grade 6, now they get to play with all the colors and they get to see how they work together. And it's not hard for them. They quite like them. They find them quite easy to work with. So this is where I would probably abandon just using the tiles alone. I would hope that by the time I get to this, that we would understand that the opposite operation here would be to take away 15. But if I took away 15 there, I would take away 15 here because I've already done that kind of work in the hands-on pieces. Algebra tiles have always been available to be used on a PAT exam. They haven't always been offered, but they've always been allowed to be used. So it's important that students need to know how to use them because they even have multiple choice questions in the old PATs where they give them the model and they're asking them to define either the expression or the equation, just like we did with the Cuisenaire rods. They have to be able to understand what those are. So they have to be exposed to them. So it's a good time. Grade 5 is a great time. Okay, any other questions about algebra? Okay, let's look at patterns then. So I'm going to just start a little bit on, let's just see if I can, oh, I'm not sure what's going on. There we are. So in grade 4, I want to go back because patterns is getting pretty big now, and we want to make sure that there's continuity, and we know it's our first year going through it. So with the grade 4s yesterday, we talked about what are the patterns. What do we call an arithmetic pattern? What do we call a geometric pattern? So we defined that, we looked at them, we figured out how we would look at number systems and figure those out. We also unpacked the Fibonacci sequence and to show what those are, where do I see them in the world? So that was simply a sequence of numbers that have a distinct pattern to them that I can predict what each number will be. But the specialty about that, or what's so special about it, is that it occurs in nature in so many places. And it's occurred over centuries that people have recognized sort of the relationship that that sequence creates. And without getting into the whole bit of it, both videos are here. We looked at this one yesterday just to get a sense of what is the sequence and what does it mean and where do you see it and who came up with this thing. And it's been around for centuries. Thousands of years, actually. But the one on the bottom we didn't watch, and this is really just, if you've watched this, then you can go to this one. This one is actually better in its visuals because it shows me the sequence, but it also shows how the sequence creates the shapes that it does. And how did we get that rectangle? And how come our windows look like that? And how come in the Parthenon, when you go there and you look up and you see, you now know to look that has that perfect golden rectangle in it. So that one is a great one, but you have to understand what it is first before we go here. This one has no words in it. It's just music in the background, but the visuals are excellent. So I'd encourage you, if you haven't had a chance to go through that. So we have gone through and defined what geometric is, and we've gone through and defined arithmetic. And that was simply looking at if I was given a sequence of numbers and asked to determine whether they are arithmetic or geometric. Arithmetic means that each number that comes after its preceding one, I'm adding by the same, what they call the common difference. I'm adding, I know difference sounds like, wow, aren't we subtracting? Well, you are actually, but in this case, and I'll show you why it's called common difference. Here I went from 0 to 2, 2 to 4, 4 to 6, 6 to 8. So I'm adding 2 each time. How do I find that I'm adding 2 each time? You take the number and you subtract the one that's in front of it. And that's why we call it the common difference. 6 minus 4 is 2. 4 minus 2 is 2. 2 minus 0 is 2. 8 minus 6 is 2. It's always 2. So that tells me the number that I'm using to add to get to the next one. If ever in a sequence, even just one set doesn't give you that consistent 2 in this case, then it's not arithmetic. It's got to keep working to infinity in that. These are getting larger because there's really no place to stop. For every number I can add another 2. So that's where the dots are there. So in this case, skip counting is another one. That was skip counting by 2s. Here's skip counting by 5s, or I'm adding 5 each time. There's another one that I could look at. In this one, it almost looks like I'm adding 2 again, but when I get to the third one, I'm not adding 2. I'm actually, the only way to get to 8 is I've multiplied 4 by 2. So go back and check. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, so this is a common ratio. I'm looking for what is the ratio or the number that I'm using to multiply consistently to get to the next number. So geometric means multiplying, arithmetic means subtracting or adding. So in this case, we went through some examples of triangular numbers, square numbers. Again, if you're unfamiliar with that, you might want to watch a little bit of the grade 4 part in the patterns there as well. So this was the information that we had in grade 5. We were talking about only arithmetic. Okay, we just really want to focus on that. So if we have an arithmetic sequence, could we figure out some kind of pattern or rule that I might put into a table of values that would represent that sequence of numbers? And generally when we do that, so I'm going to use the same one we just looked at. Generally, when we try to put them into a table of values, it means that we're linking something to a partnership, a relationship. It's a one-to-one relationship. So the very first number in the sequence was 0. So term number 1 was 0. The second number or second term of the sequence was 2. The third number or third term of the sequence was 4. So that's what these T's at the little subscripts at the bottom. It's not a power, it's just below. So T1, T2, T3. The grade 5s don't have to write it this way, but I'd use it, and I find that students understand it because they start thinking, oh, this is term number 1 is 0, term number 2 is 2, term number 3. So they catch on to that, but there's no requirement for them to do that. So when I'm trying to write this in a table of values, then what I'm really trying to do is say, can I determine a term number to have a value? And is each term number got its own value that's unique? And I can predict what it's going to be because I understand what the rule is. So for example, let's use one that's called figures. So let's say they gave us this picture and they said, we have this arithmetic sequence using figures. So term, figures, spot, first, second, it doesn't really matter what you want to call it. I have this figure number and I have the number of dots that are associated with each figure. This is a table of values. So it has a title on both sides of the columns, and I can use information given to me in order to figure out what numbers are going to go in here. So in figure number 1, I had 1 2 dots. So that's where the 2 came from. So this is my starter for the students. I would then ask them to fill in the rest of them, which is what I've gone and done already. Figure number 2, I've got 1, 2, 3 dots. So in figure number 2, 3 dots. Figure number 3, 4 dots, and so on. So for each figure that I go up, I'm going up 1 by the number of dots. So if I were to say, could you write an expression to show me the number of dots? I might use F for figure and say figure plus 1, because figure number 1, if I add 1, gave me 2 dots. Figure number 2, if I add 1, gave me 3 dots. Figure number 3, if I add 1, gives me 4 dots, and so on. So the number of dots is determined by the figure or the position plus 1, always plus 1. So plus 1 is what I'm adding consistently. That's my common difference. So to start students off, we might ask them simple questions like that, fill in tables like this. This is really taking all that you're doing here in patterning and just putting it into one sort of example. So I want them to have information that they have to take from that graph or table or chart or whatever you're going to give me. Can they put it into a table of values that looks like something like this? And they have to be able to identify what's going to go at the top, or we give them that to start with. And then I might ask them some questions that prompt how they're going to fill these in. Once I filled in a table of values, tables of values also allow us to plot points. So would I be doing patterning before I've done coordinate geometry? No, because coordinate geometry fits into patterning. So again, it's that hierarchy of what needs to happen before I jump into this. And that was one of the reasons patterns in your year at a glance was towards the end, because I need to know expressions, I need to know substitution, I need to understand variables, I need to understand plotting of points. So all of that builds into these, and that's why I said you can grab all those different organizing ideas and start building them together and revisiting them over and over. So here I'm going to revisit, how do I plot coordinates? So the first column in a column table of values is really reflects the first value in the coordinates. It's like your X column, and this is your Y column. And each row gets its own ordered pair. So here I have 1, 2, which could be written in my coordinate system as 1, 2. When I put them onto the grid, which they've already worked on and done, remember that I'm really plotting some points here. So I do need to label what's going to go. So on the bottom, I have the figure numbers. This is my X axis. And on the vertical, I have the number of dots, or my Y axis. So the way that we've taught them how to plot points isn't going to change. What we labeled them, that's just a title. That's all it is. But process hasn't changed. So to put 1, 2 on, I'm going to go 1 over and 2 up. So I'm going to put 1 point right here. 2, 3, I'm going to go 2 over, I'm going to go 3 up. 3 over, 4 up, and so on. One of the things that you will notice that when something is arithmetic, and if we consistently added the same number all the way through, those points will start to follow a straight line. So I went to 1, 2, I went to 2, 3, I'm going to go 3, 4. They will start to, if I took a ruler, I would find that all of the points start to line up. If one point as you plot them ends up over here, then that's your indicator as well visually that this is not an arithmetic sequence. You've got one odd man out there, and that one odd man is enough to say not arithmetic. So they should all line up. The advantage of that too is that I could just take a ruler. I don't want to join these as a point because they're not, they're discrete points. But I could take a ruler, the edge of a book, anything that's a straight line. And somebody said to me, well, how many would you expect to see in the 9th one? Well, then if I have enough squares on here, I can go on the 9th one and see which one lines in, and I can tell you exactly, figure number 9 will have this many dots. So I can project as I go forward because I know they all have to line up. And that's true of any arithmetic sequence. So as we unpack the patterns, they have to know what an arithmetic sequence is. I need to go back to grade 4 and make sure that we've got them well instructed from there, just what it is and how do I find it, and give me examples. I then want to give them a figure like this, a picture, could be could be a table of value, whatever you're going to give me. And then from there, I want to be able to create my own table of values or extend one that you've given me. Maybe you started it and I have to keep going and fill it in. Now that I can see the pattern that's being created, I need to fill it in. And then can I take those points from my table of value and plot them onto a grid, label the grid completely and correctly based on what I've got up here, or what did I label them up here? Maybe you started me off, but you didn't really give me all the labels, but there was enough information in a chart or in a table that I would be able to figure out what the labels would be. So it's just lots of practice back and forth that we want them to do to be able to do that kind of question. Here's another example. And what makes this one a little bit different, this was created by my colleague that works on the CPARs with me. This is one, notice it didn't start at 0, didn't start at 1. So if you keep in mind what I just said, that they always line up, I could plot these as ordered pairs on a grid. And if somebody said, well, what do you think 2 will be? What do you think 1 would be? If I can't see the pattern myself, I could just take that straight edge book, something that's got a straight line, and run it over to 2, run it over to 1, and I can see what it's going to be. Or I can project what it's going to be beyond that. And that's typically what we want students to do is, can they write an equation, an expression for this? I have a term number, which is 3, and then I've got this value that came out, which is 24. I have a term number, which is 4, then I got this value that came out. What kind of a pattern am I starting to see? Each time I have a term number, I get this value that came out. But is there a pattern? Yeah, there is. Each time I have the term number, if I multiply the term number by 8, I will get the number that's below. And I can see that. I can check it. 56 divided by 7, is it the same as 48 divided by 6? Is it the same as 40 divided by 5? And so on. So if I can keep that in the back of my mind, well, then if it's the term number times 8, well, I could fill in 2 here, and 2 times 8 would make it 16. Each one of these is going up by 8. Would 24 minus 8 give me 16? Yes, it would. So students should be able to fill in missing numbers in tables. I shouldn't always have to give you everything done. I might only start you off with just enough that you can consistently fill it in, or I might give you one here, missing here, but got this one, so that you start to have to think about what are the parts that are missing. Is it the term number? Is it the term itself? So these are the kinds of questions that would be appropriate for grade 5 patterns. So before I move on to stats, any questions on patterns? Does that make sense? Okay, let's move on to stats. So stats is all about asking questions and collecting information. And the older the students become and move their way through statistics, the more they're going to start to collect and the more refined they're going to be about what they're collecting. So as they get older, we also want them to be quite cognizant of, are you asking a question that might be biased? Are you asking a question that's really not going to represent all of the general population? It really is just asking a small group, and that small group has some really defined ideas. So you might not get data that you would get if you, let's say, stood in a mall and asked a bunch of questions. So it's, again, we start, as they get older, we start to have them really define their thinking a little bit more. So in grade 4, just so that you're clear on what happened over there, we started with what is the problem-solving process in statistics. So they have to have a question, they have to collect data, they have to represent the data, they have to interpret the data. If you think about science, for those of you who are doing science grade 5, that's kind of the scientific method from grade 2. And we added all those different steps in that by the time they got to grade 5, they're actually analyzing some of the data. They're collecting data and representing it differently. So again, I could be doing my stats unit in math along with another subject, maybe social studies or science, because they're going to overlap each other. So why wouldn't we connect the understanding so that students don't think that, oh, I only do experiments in science and that's the only time that I do them there. But then we do this question in statistics. They're one and the same. We're collecting data. So in this case, they're going to be representing data. So they're going to have a question, they're going to collect their data, and then we want them to represent their data. In other words, choose an appropriate graph to represent the data that you have, and then you can draw some conclusions from it. So they're going to engage in statistical problem solving. That's what's happening in grade 4. Well, we're doing pretty much the same thing when we talk about grade 5. We want them to have a question. We're going to collect the data, and then we're going to collect the data by defining for them what frequency means. So if I stand at the edge of the front door of the school, and everybody who comes into school in the morning, I ask them the same question, and maybe it's got 4 or 5 different answers. I put check marks for each one that gives me an answer in each of those categories. I'm collecting data. I've asked my question, I'm collecting data. Now I want to take all those check marks and I want to organize them so that I can make some sense of everything that I have. And that's where the term frequency will come into play. And then later the word mode will come into play. So mode is a word slid from grade 7 statistics down into grade 5. And mode simply means, is there a specific answer that came up more often than anybody else? Like, is there one that has the highest value? Is there one that has multiply shown up a number of times? And generally, we're looking for something that shows up, like answer A and answer B both had 200 people answer exactly the same way. That's what we call a mode. So things that have come up and shown up most often, that's really where we want to be. So in this case, we look at if there's no values that show up more than something else, in other words, identify mode in various representations, data sets with no mode, one mode, or multiple modes. So if I don't really have something that's standing out as a mode or something that showed up more often, we just say they got lots of responses, but not one of them stood out more than the others. Let's have a look at some questions that we might ask and some terminology that we need to unpack in grade 5. So I'm going to collect. I'm going to make sure that they understand what is a good statistical question, and that happened in grade 4. You might want to grab that video. It was also in your front one there. But a statistical question is a question that has more than one answer. If I just say to you, how tall are you? And you say, I'm 153 centimeters. That's it. There is no possibility of you coming back saying, oh, I could be this, or I could be this, or it could be this. That's it. There's your answer. So it's a good question. I've asked you a point blank question. You've given me the correct answer, but there is no variance in the possibilities for answers there. If I were to say, what is the height of an average volleyball player? Then I might interview all the volleyball players in the school, boys and girls, and ask them how tall they are. And then I could get a sense of, is there an area that they seem to be towards that height? Or is there a range of areas? But that's a variety of different answers. So we have to be very careful that students understand which is a statistical question, what isn't. We also have questions called open-ended and closed list. Closed list are like closed questions. How do they differ? Here's an open-ended. So which type of juice is your favorite? I'm standing at the front door of the school. I ask that question. You say to me, prune juice. Okay, not sure that kids will say that, but prune juice. So I write down prune juice. Next person comes, apple juice. Okay, next person comes in orange juice. And so I'm not limiting you to anything. I'm just tell me what you like. What do you like? Mango juice. Okay, whatever. So I write down all of those answers. And if somebody gives me the same answer, I might put a check mark beside it so I don't have to write it down every time. Versus a closed list means I still get to ask the question. It's still a statistical question, but I'm going to limit the choices. And so I'm actually asking the participants to choose one of. So which type of juice do you prefer? This might be not your most favorite, but which do you prefer? Apple, orange, or grape? Generally, when you ask a question like this, you might even have a D that says none of the above, right? Because maybe I'm really asking you a question that you hate all 3 of these, or you're allergic to all 3 of these. So none of the above should be an answer. If I ask it this way and don't give you that option, then I'm forcing your hand to maybe not give me the right answers or the right data that I'm looking for. So this would be my open-ended, this would be my closed list. So the minute I start to condense it a little bit, just to make it more manageable, and that's the reason we use closed lists sometimes, it's because maybe there's going to be so many answers, we're going to be there forever trying to organize them into some kind of meaningful list of things that we can do with them. So in grade 5, again, once I've got the question, once I start listing sort of the responses that I get, so I have my open-ended, my closed, I need to somehow organize that information. So I might have my check marks, I might do a count, a frequency count, and then I'm going to pick the kind of graph that I'm going to use to display my information. The bar graph and the dot plots will not be new to grade 5. They have done those in previous grades already. Might be new this year, but they're not new as they start to come through, they will have already done that. What is new is the stem and leaf. But in our examples here, I did leave in bar graphs and dot plots just in case we need to go back over those and they're not familiar. This will show them how we would set them up. This is our dot plot right there. And then how do I make a stem and leaf? Not a lot of them have seen those before. So again, so just some short ones in there that you might want to use for review if needed. So I take my information and I put them down. Now this one is an example of where there's a range, right? So the range, in this case, the range came, this it might be hours of homework that they spent. So between 0 and a half an hour, I'm somewhere in there. This is where they started to do their counts. So they might have started with check marks. Maybe they're using tally marks. So for every 5, we put a bar through it. Students have to be taught that. Not everybody knows that. And then the frequency is over here. Here's my frequency where I see how many, in other words, what's the total of all the tally marks that I have. So I see that most students that I was asking spend between an hour and an hour and a half on homework. That's what I found in here, that most students are doing that. Seem to be right around that time because that seems to be where most of the numbers are centered. So it's almost like saying between half an hour and 2 hours is where the bulk of students see themselves doing their homework. That's the kind of generalization we want. In here, I put a link to one of the grade 7 textbooks. This link is online that you have access to. And it's about data. So this comes from the grade 7 book. This would be a good one for you to use if you're looking for some resources. But what I want to just point out is that when we talk about the different types of data that's being represented, we don't always need to have all of the terminology for statistics. And in grade 7 previous, they have always done, whoops, I might have passed it here. They've always done mean, median, and mode, and they're not doing that in grade 5. And so it's not something that we'll just say, oh, well, you know, we're going to go through and just do them anyway. So you'll see questions in here. You'll need to select out the ones that you want. But there's lots of excellent questions that I have and that I can access in here and that I can see. So here's an example. It says, where's the median, where's the mode? We're not doing median, but we are doing mode. Is there a data value here in any one of these sets? And that's part and parcel of what we're doing that showed up most often. In this case, 4 showed up twice. So this one has a mode of 4. The 4 showed up most often. If it was just one of everything, we'd say, no, there isn't a number that showed up more often than others. And so there's no distinct mode. If I look in a table of values, I look down here and I see, oh, 4 showed up here as well. Sometimes you'll end up with 2 numbers that show up the same amount. Maybe there would have been 2 5s and 2 4s. That's okay. You can have more than one mode. In that case, we call it bimodal. And we just name that, you know, the value for the price of 14 and 17 showed up 5 times and 20 and 25 showed up 4 times. So there are 2 numbers that showed up the same amount. If one of them showed up 2 5s and one of them was 3 4s, you have one mode and the mode is 4. Which number shows up most often? That's what you're looking for. But there's lots of questions in here that you could use as models and exemplars so that you don't have to create the questions yourself. And here's just some. These come from that book as well, but here's some other ones. None of these have a mode because they're all numbers that just show up once, but they all give me data and I can translate the frequency into values. Okay, so how many students get up on their own, have parents wake them up, have an alarm clock, etc. So question is, how did you wake up this morning? So you've got lots of things that they can do. Finding questions that they're interested in will definitely make it easier for you to do the stats. And so here's just another example. Here's a term 1, I have 3 dots. Term 2, I have 5 dots. Term 3, I have 7 dots. Again, I can do that same kind of graph, that same type of work that we did before, take this information, put it into a table of values. Or could you find what the missing terms are? I went from 3 to 5, which looks like I'm adding 2. So that would make this one 7, that would make this one 9, and that would make this one 11. So yes, the common difference is 2. 11 minus 9 is 2, 9 minus 7 is 2, 7 minus 5 is 2, etc. So that's what the common difference is. So again, these are just examples of things that you might want to include as models as you're moving through the statistics. So you have, that kind of takes us to the end of everything that we're doing in grade 5. You always get some survey that's sent to you, and we'd encourage you to fill those out. I know that we get surveyed to death. They only take a minute. But the important part at the end of the year is kind of what are your needs for next year? Now that you've unpacked the new grade 5, you've been through it once, what would be helpful to you as round 2? So you've kind of learned a little bit about each one of them, going through some other units again, adding more into some units, assessment, like what would be helpful to you. So when you're filling out your surveys, that would be an important thing that you can put in and have. The CPAR documents are another piece that you have available to you that are building those organizing ideas with exemplars and looking at illustrative examples. More of them are being posted as we move forward in grades 4, 5, and 6. So you just need to keep checking back to the sites. So there's the New Learn Alberta, which gives you your curriculum, access to boards, resources that they're suggesting. Also, we have the ARPDC site where all of the consultants are posting the work that's been done in each of the subject areas. And then for you in math, we had said early right up front, you might want to download the K-3 and 4-6 verbs, all those verbs that you have in your skills and procedures, and sometimes your organizing idea, and sometimes in your learner outcome. What do they mean? And so having sort of a common approach with some exemplars might be a good thing, that we're all talking that same language as we move forward. Okay, I'm just going to stop the recording here first before we move forward. Let me just grab this. Why are we not stopping here? There we are. This has a mind of its own today.